Hello everyone, welcome back to mathematics. I don't know if you guys still remember in the previous section we talked about the relation between two quantities, and that relation, it varies in a certain pattern we call a function, right? Today in this video I'm gonna talk about specifically about three variation relation between two quantity, and we'll be talking about the application of that variation of that relation between two quantity or three quantity, more than that. Okay, so let's get started. So the topic for today is variation. Okay. The first variation relation between two quantity I would like to discuss, we call that direct variation. Okay, direct variation. So what is direct variation? Direct variation is a variation between two quantity when the second quantity increasing or decreasing depends on the first quantity increasing or decreasing respectively. So what I mean is that if the first quantity increasing, the second quantity is also increasing. If the first quantity is decreasing, then the second quantity is also decreasing. And the formula, okay, the formula for that direct variation, for that variation is follow. It's as follow: y equal k over k times x. So the first quantity here, let me write over here, y equal k times x. So the first quantity here is y, and the second quantity here is x. Okay, so we're gonna read this as y. This is y varies directly as x, or I can read it as y is directly proportional to x. So we have two quantity. We compare two quantity here, and the k value here we call the constant of variation. Okay. Now let me give you an example. I have something like this. If y vary directly as x, okay, okay, so not good. So given that y vary directly as x and y equal 5, and y equal 5 when x equal 30. Okay. What is y equal 5 when x equal 30? What is y when x equal 72? Alright, something like that. Okay. So then we know that y vary directly, so we're going to use this formula. So we're going to use y equal to kx. And we have to find the constant of variation. So we know that y equal 5, x equal 30. So from here, we can find k is 5 over 30, which is 1 over 6. Okay. Then we want to find y when x equals 35. So k is equal to 1 over 6 times x is 72. Sorry, x equals 72. Then your y here will be 72 divided by 6. Will be 12. That's the final answer. Okay. So in order to solve this problem, you see that we need to find a constant of variation. Constant of variation is very important. Okay. Without constant of variation, then we cannot find the y value, right? Okay. Let me give you another one. What if I have this problem right here? Let's see. Now let's see. Let me get another one. Let's see. Let's read problem about allergy medicine. Oops. That's it. That's physical described for a child very directly. So this you see that it's very directly. Okay. As the weight. Okay. So amount of allergy medicine. So the amount of medicine. So I'm gonna call it A, very direct as the weight. So A, the equation we're using will be A equal KW, right? So that's the equation of variation. But we need to find a K in order to get the equation of variation. So we know the 13 milligram, so which is 13 milligram, 13.5 here. K equal to 30 pounds. So your K will be 13.5 divided by 30.45. So from here we can get the equation of variation will be 0.45 W. This is the equation of variation. Okay. How much should it be described for a 50 pound child? So how much should be prescribed? So I mean they're asking you for A. So A will be 0.45 or multiplied by 50, which is 22.5 milligram. That's part A. And you do the same for part B. So part B, you're going to just go ahead and plug them in. 149 times 60, which is give you 27 milligram. Calculator. Right. See. Another one to double check the doses with Dr. order for 50 milligram for a child of what weight? So they're asking you for W now. For the dose is 50 milligrams, so we're gonna plug 18 milligram. Sorry, 18 not 15. Equal to 0.45 times W. Excuse me. So from here, take out W. 18 divided by 0.45. Which is equal to 40. Okay, 40 pounds. Okay. Okay, they're asking for a child of what weight? So 40 pounds. Okay. So that's the first type of relation. We call that inverse relation. We call that direct variation. So the second type we call the indirect. So sometimes we call the inverse variation. Okay. So this is indirect variation. Okay. And the formula equation for indirect variation or inverse variation will be y equal to x over k. I'm sorry, k over x. So the difference between this and this, the indirect and direct, is that for the direct one, if y increasing, x will be increasing. If y decreasing, x will be decreasing. But if this one, for indirect one, it means if y increasing, then your x will be decreasing. Okay, and vice versa. Right? If your y is decreasing, then your x must be increasing. It's the other way. Okay. But for the first one, is when x and y increasing at the same time or decreasing at the same time. So for this one, if this one going up, then x going up. If this one going down, then x going down. Okay, but this is kind of the same thing. Now let me give you example. I have problem like this. Let's see. Why do I have this? Example number 1. The U you know what? I think I'm gonna just go ahead and copy them down. So I have a problem like this. Okay, let's see how we do that. Alright, U bond very inversely as the price, so it will be U equal to K over P. The U is 4% when the price is 100. The 4% when the price is 100. So we can find the K right here. So K will be 400. Okay. Find the U when the price is 80. So from here we can get the equation will be 400 over P. Find the U when the price is 80. So the U when the price is 80 will be 400. The price is 80. So 400 divided by 80. Only 5%. Alright. It's kind of the same as last time. The only difference is the the k, and the other quantity will be in the denominator. But other than that, I think will be the same. Okay. Let's see, I can find another one. Alright, what if I have this problem? Symbol 2. Okay, the time required to complete the job in very inversely as the number of people. Okay, so okay, time inversely k over number of people. If we take 8 people, 12 days to do a job. 12 days, so 12 k over 8. So we need to set up the equation of indirect variation. 96. Okay. So the equation will be t equal 96 over n. How many days it take if 15 people on the job? Okay. So t equal to 96 over 15. Okay. So it will be only 6.4 days. 6.4 days. Okay. And part A. Part B. If the contract wants to do in 8 days, how many people? Okay, 15 people. 8 days, so time is 8. How many people? 96 over n. So try to find the number of people. So n will be 96 over 8. Will be 12. So will be 12 people to finish the work in 8 days. Okay. So that's the inverse variation or indirect variation and direct variation. The third type of variation relation is that we call it joy variation. Okay, joy variation. Joy variation is just another version of direct variation, but the joy variation it contains more than 2 variables. Okay, more than 2 variables, and we can also combine direct and indirect variation into one. So you can combine joy variation and indirect variation together. For example, I have something like this. I can have the formula for joy variation as follows: y equal to k. So instead of kx, right, we might have kwx. So this formula here is a relation between 3 variables y, w, and x. And this is also, you see, this is nothing but direct variation, because the indirect we have a fraction. Okay. I can give you example like this. What if I can say y varies jointly, okay, as t and cube root of x. So I can from this statement I can write a formula will be y equal k t cube root of x, k t times cube root of x. Okay. So this is joy variation. Or I can have something like this. I can have a combination between joy variation and indirect variation. Okay, what if I have this W, okay, very jolly as jolly as jolly as 4 power okay of D, and indirectly as square of it. So this is it's a combination. Okay, this is a combination of D and H. So we can write Y as K D4 over H squared. I can write like this. Or actually, this one I can change it. Join as the 4 power of D and K. Oh, and square of H. I'm sorry, and square of H. Okay. Okay. Let me see. So, and square of H. And so in square of H. And indirectly as cube root of H, cube root of K, yes, cube root of K. There you go, something like this. This is better. Okay. So you see that it's a combination of joy variation, which is more than 2 variables, right? D and H, and we have indirect variation for the K value. Okay, so you have to be flexible. So you gotta read the word, okay? and you read the word, you can get the formula. So the formula is very flexible. It's not just like this. Not just like this. Okay, it depends on the problem. I can give you another problem of calculation. Okay, whatever have the problem like this. Kinetic energy of an object very jolly as the weight of the object and square of the velocity. So kinetic energy K. Okay, let me use another energy E equal to K. Joy variation is constant. Weight and square of the velocity. So we have something like this. During hurricane, 0.5 storm travel from the western ham. 81 joule kinetic energy. So we can set up the equation of variation. So 81 by finding the K. W weight 0.5. V is 60 square. So from here, I can find K. 1800. So K will be 0.045. So from here I can get the equation of joy variation will be equal 0.045 WV square. Now that's the equation of variation. Now what if the wind speed double to 165 the kinetic energy? So E with 0.045, W is the same 0.5, but the velocity is double. So the kinetic energy will be more, of course. So it will be 324 put into the calculator joule. Okay, that's the unit for energy. Okay, so for the joy variation and a combination of everything, you have to read the problem. So based on the problem, you can write the formula, then write the final equation. So this is the equation of joy variation. Okay, so it's not always simple like this. If it is simple like this, it will be easy. If it is like this, then you can read this as y varies joyly as w and x. Okay, but sometimes they can combine it. They can combine everything. Okay, good. Alright, now if you have any question, please let me know. So again, in order to be good at this concept, you gotta do a lot of word problem at it. Okay, when you do the homework, if you have any question, just take a screenshot and send it to my Canvas message, then I'm gonna help you. Okay, or come to visit my office. Alright, I will see you next time. Bye bye.